because I do definitely want to record the meeting because I think it's important so you guys can go back and take a look. Because how many of you, give me a thumbs up with your little reaction that you do like to go back and look at the work that we did. Give me a thumbs up because I'm going to do it too. I'm going to go thumbs up. Boom, look at me go. All right, so I'm going to go back to sharing my screen. And right over here, I asked you guys to evaluate these, right? And what the heck are you doing? Like, what is this? This is a log. I mean, I know I threw a video at you on Friday. It was a pretty damn long one too, I know. But Mike, what is that? What the heck? What is this? What is this asking you to do? Who wants to take a shot at number one and say, hey, you know what? I think I know what number one's asking to do. Anyone?
I'll do it.
I can try it.
Darcy, go ahead, sister. I saw that hand go up.
So the 8 is the base. So basically what you're trying to find is what number, well, it's like we'll use like x, like what 8 to the x power equals 1 over 64.
So I can rewrite and I can set that equal to x, right? I can take that log base. Can everybody read this with me? Log base 8.
8.
Log base 8.
Base 8.
Log base 8.
1 over 64 is equal to some number x, right? Which Darcy says you can rewrite this equation in terms of an exponent. So you said you're going to rewrite it as what, sweetheart?
8 to the x power equals 164.
Is equal to 1 over 64.
Wait, 1 over 64.
Right, you're doing great. Yeah, so like in other words, you can take that. So you're saying 8 to some number is going to give you 1 over 64. What is that, my friends? What is that number that we speak of?
-2.
Negative
It's
2.
-2. So did we all get -2 for the first one?
Yeah.
Good.
Yeah.
So x equals -2 for the first one because 8 to the -2 is equal to 1 over 8 squared, which is 1 over 64. So we're using those beautiful exponent properties. What the heck is this up with this guy? I don't see a base here. Wait a minute. There's no base. What do I do? Billy.
You just use base 10 since
Yeah,
that's
you
the
would
normal.
say base 10. If there's nothing there, put a damn 10 there, okay? Why did we choose? How come we don't have to include the 10 there? How come we can assume it's 10? Where did that come from? Where did that
Since
come from?
10, since we use base 10 in like normal life.
Because we use
We
base
go on,
10 in normal
yeah.
life. Exactly. Our number base is base 10. So again, I can rewrite that as x. So we're saying 10 to some number is equal to 1,000. And what number is that? If I do 10 to some number is equal to 1,000, what is that number?
3.
X is equal to 3. Bravo, brothers and sisters. Look, I have my pen upside down. Look at me go. So x is equal to 3. And then finally over here, I have log base 2 of 1 over 28 is equal to x. So 2 to some power, right? It has to give me 1 over 128. Sherry, what do you got for x, kid?
-6.
Is it -6?
-7.
I got -7.
I think it's -7 because I think 2 to the -6 is 1 over
I got -7.
60.
right?
Yeah.
So you should have 2 to the -7 is 1 over 2 to the 7th, which is equal to 1 over 128, right? So we can use our laws of logs and using our exponent properties. Okay. So when we started this, so I read some of your reflections, and I think some of you were super insightful. I think some of you were half-assed about your reflections, I'm not going to lie. So for those of you who know damn well that you were half-assed about your reflections, go back and redo them and make sure that the problems that I asked you to do in the video are done. I'm going to give you another opportunity to redo that before I actually grade your reflections and the things on there because it is going to count as a grade. Okay, so let's go back. And the thing I had you guys follow along with, did anybody print this out or does anybody actually have a copy of it? Because this was something I believe I assigned to you like a couple of weeks ago. So this should be something that you have
that out.
a repertoire, right? Okay. So what's really cool about this is that now we have something in our repertoire. Like in other words, we know that a logarithm is a what?
Inverse?
Hmm?
Inverse?
It's an inverse of an exponential function. Isn't that interesting that when we were studying other inverse functions, like the inverse of something squared is the, Krisha?
Cube?
Krisha, what's the inverse of something squared? If I want to undo something squared, I would take the square root. Jonathan, if I have something cubed, if I want to undo something cubed, I would take the cube root. If I want to do the inverse operation of multiplication, you're all going to scream at me that it's going to be
Division?
division. But then I say to you, you know, what's the inverse of an exponential function? You're all going to say logarithm. Isn't that interesting? So you should look up John Napier. John Napier is the dude who was messing around with these and why he eventually called it a logarithm. Because one of you asked, why is it called a logarithm? I'm going to put that on you to find out and then bring it to the next class. So let's jump in here and let's get in to what we need to do. So as we're doing that, the cool thing is let me see. The only person we are missing is Barack. Can anybody figure out how to reach out to Barack for me so he doesn't miss this? And then we'll be okay. Anyhow, getting back to this represents an exponential function, right? Where A represents the initial amount, B represents our growth or decay factor, and noticing that B has to be greater than 0. So your base can never be negative. And we're going to talk about why, or you guys are actually going to figure out why there's no way in hell that you can have a negative base, because we're talking about exponents. So, you know, like if we had, like when I do 1/2 to the x power, first of all, is that a growth or a decay, my friends? Is this an example of a growth or decay, Amanda? Is this a growth or decay?
Decay.
Amanda, I can't hear you. If you don't, thank you. It's a decay because, and it's basically saying that you're always going to be how much of your previous amount, everybody?
1/2.
You're gonna be half of what you were before. So if you were 10, now you're gonna be 5. Then you're gonna be 2.5, and then you're gonna be
1.25.
1.25. And what's half of 1.25, and so forth. So, you know,
1.25.
there you go. So you guys are doing a great job. All right. So when we started here during the 2000s, Colombia increased its annual percentage rate, the population, by 1.5%. The original population was 40.26 million. What was the exponential function that represents this situation if your population growth is 1.58%? And I'm gonna look down at my paper here. Erin, can you give me the function?
F of x equals 40.26 times 1.0158 to the x.
Does everybody agree with Erin's function?
Yeah.
Yes?
Yeah.
Yeah, I do too. What's the base? So if we were looking at this as an exponential function, what is the base of this function?
The base is 40.26.
No, it is not actually. The base is not 40.26. What does the 40.26 actually represent? Everybody.
The initial
The initial
Initial
amount.
population.
So if I said to you, what is the base here?
Initial
What are you all going to tell me the base is?
1.0158.
Right. This right here is your base. So your base is equal to 1 point, that's your base, I'm going to go like that, is 1.0158. Okay? So now
C-Schwab,
if I say, yeah, hon?
wouldn't the x for this case be x minus 2001?
No, because what we could do is we can say let x equal, we know that 2001, we can say that at t equals 0, we know that we're talking about 2001. So you can set up that thing over there, right? So that, because otherwise it starts to get a little crazy. So if you know that you're like, okay, if I let t equals 0 represent the year 2001, then I know 2008 is how much later.
Okay, makes sense. Sorry about that.
2008, right? So 2008 would be t is equal to what?
7.
Jolie would be 7. Would you agree?
7.
Okay, good. So now if I wanted to, I could just plug 7 into this function and I could go ahead and I can call it a day. Is everybody okay with that? Yes? All right. So now the next thing I asked is when is the population going to reach 82 million? So now we're going to set f of x, which is y, equal to 82 million. And now we have our 40.26 times 1.0158 to the x power. So now when we would go about solving this, the first thing we would do, like if we were to do this, if you remember, we did this graphically before. And when we did it, we would technically go ahead. I'm going to jump in here to Desmos. Just bear with me here. We would jump over to Desmos. And in Desmos, can you guys give me the function when this thing finally pops up? And I feel like my internet might go down at some point too, so just bear with me on that because it's just it's so temperamental. Do you guys have that issue too?
No.
You guys aren't having internet issues? Well, you don't have Optimum, do you? I do.
Yeah.
Yeah, whoever has Optimum, who has Optimum? Anybody have Optimum?
I do.
Maybe.
Yeah, does it go down? Do you find that like your internet goes down every once in a while and you're like, uh-oh.
Yeah.
Yeah, it's
Yeah.
annoying.
My phone disconnects from it all the time.
Yeah, and I feel like it's doing this right now. So 40.26, right, times 1.0. Can you see what I'm doing?
Nope.
No.
No.
Oh, hold on a second. I have to go back and hit stop share and then go to change my screen so now you can actually see what I'm doing. Okay. All right. Can you see it now?
Yep.
Okay. So now we have 158. Thank you. If that happens, let me know that you can't see what I'm doing because I forget that I have to 58. This is, wait a minute, 158, and that's raised to the x power, right? And then I have to move you guys out of my way here. Minimize you little knuckleheads to get you over here so I can't see you. So now if I go and hit graph that, you can't see it. How come when you look at this, I can't see the graph?
It's
Why is
just-
it that I can't, like, why, what the heck is going on? What's that?
Your domain and range restrictions are too small.
Right, this axis is way too small. So if I zoom out, right, now we can actually see what the graph looks like. Is everybody okay with that? So now we can actually see that there's a nice exponential growth, and we have all this going on here. And now typically what we would do is we would do y is equal to 82, right? And then we would find that point of intersection to say it would take 45.378 years for the population to reach 82 million. So before, you guys are with me, right, that we would do it from a graphical perspective, we would find the point of intersection, and then that would help us figure out what the actual population is. Would you all agree with that assessment?
Mhm.
Yes or no?
Yes.
Okay, I need a yes from you guys so I know that we are good. So I can close this out and go back into my workspace. Hold on a second. New share. Oh, I have to do a new share. That's why I have to go over to here. Okay, so here we are. Thank you for your patience. All right, so now we're back here, right? And we actually showed it graphically. So we showed that, we showed this out graphically by doing, okay, we have this function, where that's 40 point, and then we have a line going over here, and we found the point of intersection graphically. But now we want to figure out how to do it algebraically, right? So, and we now know, like, one of the first things that anytime we want to solve this, what would be the first step in this process of us solving? Say divide by 40.26, everybody. Right? Divided by 40.26. Can you guys give me that value? So what does that give me? What's 82 divided by 40.26?
2.04.
2.04.
What is it, hun? 2.0. Let's go out like a few more decimals. Let's go out a ton, like
2.04
decimal places. I say that so that we can get a better accurate answer. Go out. So I'm going to say 0.3676. I kind of like that. Okay, is equal to 1.0158 to the x power, right? So we have this now. So now if I want to figure out what to do, I'm getting backlog, and it's annoying. If you know who you are, can you please? Okay, so right now, this is an exponential equation, right? So if I have y is equal to ab to the, a to the x power, a to the x power. How can I write y equals a to the x power as a log? Like, in other words, this is the exponential form, but we can always rewrite stuff. We can always rewrite stuff. You guys, please mute your screens. I'm having a hard time here. Whoever's got that. We should be able to rewrite it as an exponential. So I have log base of y equal to x. Okay, whose screen is doing? It's weird because you guys are all. Hold on, this is really driving me nuts.
I think it might be Nate.
I'm sharing my screen here. Okay, so hold on, 1, 2, 3, 4, 5. Okay, so you're all here. All right, good. I'm gonna go back to sharing my screen again. Okay. All right, so I'm gonna call you one at a time. Let me see, jumping on to Billy. Billy, do you agree that if I have this in exponential form, that this is the log form of that exponential form, yes or no?
Yeah.
Okay, good. All right, so now that I'm over here, so in other words, this is your y equals a to the x power. So now I'm going to ask Sean, get ready. How would I rewrite this in log form? Sean, how would I rewrite this in log form if, again, I can look at this as this is y is equal to a to the x power. I'm ready whenever you are, Sean. Sean?
You can say log
It's log base a, right? And who's the base here?
base is 1.0158.
Beautiful. Of y, and who's y here?
Y.
So in other words, isn't this y equals a to the x power, right? This is y equals a to the x power, right? So in other words, we're saying we can rewrite this as log base a of y is equal to x. So I have log base 1.015 of 2.03676 is going to be equal to x, because I'm trying to find out what the exponent is. I'm trying to find out how many years it's going to take my population to grow to 82 million. So in other words, I could take this equation right here and I can rewrite it in log form. And that's exactly what I'm going to do. So ladies and gentlemen, get your calculators out, okay? Get your calculators out. And some of you might have a different form. So by doing so, I'm going to go into mine. And I just want to know, I have to go to share screen again. So hold on, new share. And my new share will be this. Can everybody see my calculator? I'm assuming you can all see my calculator, yeah? Can I get a thumbs up from people? Thank you. Sean gave me a thumbs up. Bravo, bravo. Okay, so when we type it into our calculators, remember you go to math and then, oops, and then you scroll down to, whoops. You scroll down. I'm sure some of you already know how to do this, log. And then on my calculator, it allows me to put the base in, which was 1.0158 of the y value, which was, I don't have it in front of me, yes, I do. Hold on a second. 2.03676. And if I hit enter, I get 45.377, blah, blah, blah. And if I go ahead and show that on my thing here, I get the same thing on here as I do on my calculator. Okay, did everybody see that? You all see that I have whatever I have on my calculator is actually that point of intersection that I get from the graph on the Desmos. Is everybody okay with that? Can somebody put if your calculator does not have this setup like I do, who's got an older version? Give me a thumbs up if you have an older version and you haven't figured out how to use the log button on your calculators. Are there any of you who have done that? Are any of you struggling with that? Anyone? Anyone? You all have this here. You all have this where it pops up on your calculators. Can I get a thumbs up? Eli, do you or no? If you don't, you have to speak up, guys. I can't like chase you down. You have to be the ones to say, I don't have it. So speak up and I can tell you what to do right now on your calculator. So you have to turn your calculator on. So Eli, do you have an older version?
I don't have it.
Do you have an older version?
Yeah, I have the TI 83 Plus.
Okay, so I think on yours, because I think I have the 80, I have an old one too. So everybody, while you're waiting, hold on a second. That is not what I wanted to do. While you are waiting, I'm going to reshare and do a new share and go back here real quick. Just bear with me here. And then Eli, I will show you what to do on your calculator while everybody does that. And okay, so for you guys, the first thing I want you to do, can you all see my screen, yes or no? Can you all see that this is the cup of coffee one? Yes, okay. So let's get started on that by writing the function. And then I want you guys to jump down and I want you to do letter C after you figure out you're gonna do letter A, which you should probably already have, but then I want you to find out what letter C is. So now Eli, on yours, if you arrow down, you will see that does yours have, hold on, let me pull mine up because mine's old too. So math I have one of the older versions. So when you scroll down and you have log base, does your base, can you see my picture, my face? Eli, can you see my face or no?
Not really.
Not really. Okay. So on mine, does yours say log base and then there's an open parentheses? Like when you do math and you scroll down.
Under math, there's just nothing with log.
Really
There's nothing with log.
interesting.
Yeah.
Okay, well, just bear with me. I'll
There's
see
a
if I
separate
can
log
find
button
it.
farther down on the left side.
What, sweetie? Say that again.
There's a separate log base, like on the left side of the calculator next to 7. There's a separate log button.
Yeah, but that's for base 10. You see how like in the up there it says 10 to the x? Do you see how that says 10 to the x on yours,
Yeah.
Eli? Yeah, so that's only for log base 10. So
Yeah.
we don't have a log button at all. I'm gonna have to show you a trick afterwards, okay? Okay, I'm gonna have to show you a trick after, so just bear with me.
Okay.
Because yours might not do any other base except base 10 on yours, and they could do something, there's something called change of base where you could take any exponent and rewrite it in terms of a log base 10, okay? All right, so for those of you who are chilling out over here, first of all, is this a growth or a decay? Ricky, is this a growth or a decay?
It's a decay.
It's a decay, right? And so on our function here, this is technically, it's saying C of t, so we should have like C of t is equal to, there's 225 milligrams of coffee, and then can I have my B? What's my B, my base here?
0.84.
0.84, because that's, you know, if you're metabolizing 16%, that means there's 84% left in the body to metabolize. Is everybody okay with that? We've done these problems as far as setting up exponential functions, so I don't want to, you know, go absolutely nuts. So here, what is the base here? My base is, everybody, what is my, Jonah, what is my base? Jonah, I'm waiting for you to tell me what is the base of this function, meaning the exponent, or the base of the exponent. Jonah. Jonah? George? I'm assuming since I can't hear either one of you, you're not in class because I can't see your faces. So as of right now, I'm marking you absent until you tell me otherwise. So as of right now, neither one of you are here. Okay, there's one. Where's Jonah? I don't see Jonah. George, what's the base? Your mic isn't working. Then take a piece of paper and hold it up and tell me what the base is. Okay, everybody else, we're gonna jump down to letter C. And it's saying, when is there gonna be 20 milligrams left in the body? So that means we're gonna set the function equal to 20, and we're gonna have 225 times 0.84 to the x. George, did you write down the base? I'm waiting to see what the base is. So on a sheet of paper, I should see it. Everybody else, how many of you are like, we're gonna divide both sides by 225 first? Nope, the base is not 225. Okay, guys, when we have y equals ab to the x power, yes? What does this represent? George, put your camera back on. You don't have the right to turn it off. What does the a represent in here? Somebody give me what the a represents here. Sarah, what is it, honey?
The initial amount.
Thanks, sweetheart. Okay, I'm getting a little frustrated because I'm realizing that some people aren't reading and watching the videos the way that they're supposed to, and it's really starting to disappoint me, and it's really starting to enlighten me. What does this B here represent? Everybody.
Change.
The base. George, what is the base
Base.
of this function over here? So now everybody else, we're gonna divide both sides by 225, right? We're gonna divide both sides by 225, and then 20 divided by 225, whoops, clear that out. 20 divided by 225 is equal to 0.088888888, right? So it's going to be 0.08889, and that's going to be equal to 0.84 to the x power. George, do you have a base for me, sweetheart?
He sent it in the chat.
Did he? What does it say? Can you read what it says in the chat for me?
It's 0.84.
Thank you. Thank you. Proud of you. Okay, bravo. All right, way to stay in there. Now, again, this is an exponential equation. So we're trying to figure out 0.84 to some number has to give me 0.8889, right? So now the thing is we want to take this and we want to write this exponential form and rewrite it in log form. So Cameron, how am I going to rewrite this in log form?
Logarithm.
Yep, so go. So how am I going to rewrite that? I'll even use a different color. Log.
Log base 0.84.
Yep, your base is 0.84 of.
And then 0.08889.
Okay.
Wait, Seashwa,
Yeah,
I have another class that I have to go to right now.
that's fine. You just go and just finish watching this afterwards. We're
I
almost
do too, I think.
Okay.
all right. Same for
Thank
anybody.
you.
Anybody
I
else?
do too.
has to go,
Thank
okay?
you.
Thank
Thank
you.
Eli, are you
Jonas-
still here?
Seashore, by the way,
Eli, are you
Jonas says
still-
his
Eli,
thing is
you are,
frozen.
right? Okay. So Eli,
Yes, I
I'm
am.
going to show you something on your calculator that will work for you every time, okay?
I'm
So-
here. Yes, I don't know.
All right, so what I want to show you guys, I'm glad you're here. So what we're going to do is
Okay,
there's
thank
one
you.
way to do this is we're going to do the math. We scroll down to, I need the, I don't know what the, it was 0.84, right? And then this was 0.08889, and we would get that. Eli, I hope you're watching. So since you only have base 10 on your calculator, you're going to do the log of 0.08889, whoops, 9, close your parentheses out. Whoop, I need to put a parentheses in there, okay? And you're going to do divided by log, okay, let's try this again. 0.08889, and then you're going to divide that by, I see what I did here. Okay, log of your 0.84. Okay, so, and you'll notice you get the same exact answer. So for you, Eli, when you have,
Okay, so your base goes second.
yes, so in other words, they're both being written as base 10. So in other words, here, let me go into, let me go and do a new share and go back into this over here real quick and just to show you what I'm talking about. So now when I'm in here, I am saying that when you have, where am I here? When you have log base A of X, you can write it as log of X over the log of A, because this will always, this is basically what your base 10 is. So since you only have base 10 on your calculator, that's how you're going to rewrite all of your log numbers. So that way you can go ahead and figure out what it is that you need to do, because that's all you have. You know what I mean? Okay. So that's why I'm just saying to you that that's.
Okay, but wouldn't it be log Y over log A because you're.
Well, no, it's the log of X over the, look at what I have here. I have the log of X over the log of A. So for example, okay, and everybody can test this out on their calculators, right? So if I have log base 2 of 8, right? I'm doing log base 8 divided by log, I'm sorry, log of 8 divided by log of 2. And right now, this is assuming this is base 10 and that's base 10. Eli, I'm betting the farm that if you do the log of 8 divided by the log of 2, you're going to get 3. Can you please go do that on your calculator for me now? And I will show you why that works when we start doing log properties.
Yes, it does work.
It does. I know it does. And I will show you guys why that works when we start going through log properties. And we're going to basically use the laws of exponents to segue into laws of logarithms. So therefore, that's going to be your way of doing your calculations because you have the old school calculator, but which is awesome because the thing is that, stop here. So because the thing is, oh my God, the thing is that's how we're going to be figuring out what it is that we need to do. Okay. Now, for these problems, for 3, what I want you guys to do is I want you guys to figure out how to do number 3. So after you get off this call with me, I'm going to put together the video for it. But again, it's going to be one of those things where you're going to be using laws of logs. I'm sorry, you're going to be using logarithms to actually solve out some of these problems instead of just using Desmos. But you can always use Desmos to confirm your answers. Okay. So you're going to reflect on the video that I'm going to put on here, but I also want you guys to do that number 3 that I just put up there. And then, yeah, we're just going to call it a day. Okay. Are there any questions before I go? Are there any questions before I go? How many of you think you probably need to go back and watch the video from Friday also? Thank you. I like your honesty. Good. Some of you do. Yeah, some of you do. It's okay. That's the whole point. Go back and rewatch it because I know you probably tried to skim and pass through some of the video because I know it was like 35 minutes long. So otherwise, how we doing, gang? We good? Are there any other questions?